I will talk about the correlation between the hysteresis model and the thermal analysis, introducing also new technique, but new for many of this kind of experiment, that is the digital image correlation. I apologize because my work is not complete. At the moment, in fact, in the proceeding there is not my paper definitively, because we are at the beginning of the experiment. No, we have made a part of the experiment, but we are not sure about some of the conclusion. Then I ask also to you if you have any kind of suggestion for complete my paper. I hope that with the last campaign of test we can complete and be reliable about the results, sure about the results will be reliable, and we can try to send the paper to the review of the association in the next future. You know, probably in other conference we spoken about the information of the thermography and the temperature on the state of a material or a component. And normally the temperature is a very important parameter of it. But there are generally two kinds of ways to pass different normally. There is one linked to the definition of the thermoelastic properties and the thermoelastic response as a non-destructive testing and information about stress analysis. And normally there is the intention to use normally a limited amount of stress and filtering the response in order to have a good correspondence between the thermal answer and the input in terms of mechanical loading. Another way is to use techniques linked to the dissipation. And we are working for many years, since the 80s, to this kind of analysis to find something linked to the fatigue limit of the fatigue curve. This is linked to the effect of dissipation, and not really interested to the thermoelastic aspect in this case, even if the two aspects are always together, very, very strictly linked. Regarding the fatigue limit, let me spend also 1 minute about the memory of Professor Paolo Lazzarin, because we worked, we initiated our career together many years ago in the same competition. The examination was La Rosa and Lazzarin, one and the other together. And we spoke just a few days ago about the strain energy density and the possibility to see it using some kind of experimental test. And about the fatigue limit also, because the possibility that the fatigue limit exists or not is a question very, very difficult to define. Probably the correct point of view is to see together the aspect of crack from fracture mechanics and fatigue from engineering information. I don't know if we will find a correlation between them, you can answer to this problem, to this question. Our techniques normally use the thermography to define the fatigue limit, but also the fatigue curve, and also Professor Gitano said just a few speech before. Also the possibility to see also the correlation between the effect of the linear behavior of a material respect to the loading to the input. And at the moment, the aim of the paper is that in case of low cycle fatigue, is important. We work with an amount of load very large, and then the possibility to see really correctly the temperature answer, the thermal variation, need to consider together the thermoelastic effect and the dissipation. And we try to introduce the digital image correlation because, of course, the information coming from the testing machine normally are affected by a lot of errors, clearances, deformation of the machines, slip of the grips and so on. And then we try to do it, but at the moment we have some results that are in contradiction with other, and we prefer to show actually the state of the campaign to complete in a second moment. Regarding experimental setup, the digital image sequences are with a monochromatic video camera, good enough, but it's a commercial video camera. Thermal images taken from two kinds of thermal scanners, and FLIR A320 and FLIR SC2000, with the possibility to detect as far 60 frames per second. This is an image of the experimental setup. Normally we use two kinds of specimen. One specimen longer and the other shorter. The first one, because we try to do any kind of test in tensile condition. Then with the loading ratio greater than 0. But we have some bad surprise because it's very difficult to find it when you use this kind of experiment and the plastic deformation begin to appear. Then this is the information about the thickness and the dimension of the specimen. The specimen is one painted in black for the thermography, and in white and with a little spike made by airbrush. Is a technique that we have also used from many kind of experiments. And first of all, the information about the static tests, and the dynamic test made in this case. Instead of the table, I prefer to see the image that show clearly the kind of loading we have applied to the first group of specimens. Then you see that also tensile loading, but in any case we don't have a tensile response. If you see on the bottom there are the tensile response in terms of loading. The information, the input was in terms of displacement, and the response was in terms of loading due to the plastic deformation, since the fourth step of trend was step of 100 cycle for group for each. You have not good information. We have also compressive condition. the first information about the DIC displacement and the machine displacement was very impressive. The difference between one and the other is of the order of 100% or more. Then to have information by the testing machine is absolutely useless for this kind of analysis, because the response in terms of displacement is false. And you see that there is the difference between the DIC strain and the machine strain as very, very different, and at the same time on the figure you can see in gray the DIC displacement, and in red the machine one. In this case, under loading control. In any case, we can see on the top there is the traditional hysteresis response in terms of displacement or strain, and we can see the difference of temperature. Each train has two information. Each train corresponds to one of these, and is different in terms of course, of strain, but also in temperature. The amount of the temperature is very different for each step. Every one of each is 100 cycles, but the increase of the temperature in this case is different from this, and always increasing from one train to the other. The same information arrives if we use a cyclic application of loading. In this case, under loading condition, this is R equal -1, then symmetrical, and in this case you can see the difference of these steps are very clear. Then, in terms of dimension of strain of temperature, that is linked to the thermoelastic effect, or in terms of dissipation, that is linked to the difference of temperature, the mean difference of temperature, we can see that there are different behavior as a function of the hysteresis involved. This summarizes the first result we had in terms of hysteresis area and the variation of temperature. You can see there are for different kind of cycle, and obviously each train is increasing with respect to the other, and there are quite good correspondence between thermal variation and hysteresis area. This is in terms of mean value, but also in terms of increment in per cycle. Then, actually, I am not. I just ready for the conclusions. Our test actually say that there is a good correspondence between these two parameters, average temperature and amplitude of the thermal response. But we are not sure yet, still sure about the possibility to correlate in a reliable form the DIC information with the then the area of the hysteresis cycle to the thermal response. We are working on this campaign new tests, and we hope we will give the results in the next future.